Hello. Good afternoon. It is afternoon where you're at. Afternoon for me, and it is a good one. It's actually a beautiful sunny day today. Let us these around here. Make sure I can see the chat. What's up, Beata Graf over in the YouTube? Nice to see you, my friend. Is that getting cut off? It's getting a little cut off, is it? All right. All right, there we are. So yes, welcome. First of all, thanks for watching. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is the Deep Dive, which is a weekly live stream where we work on stuff related to CircuitPython. It was originally started by Scott, the lead developer of CircuitPython, but he is still working a bit of a reduced schedule, coming back from parental leave. He had his second child recently, and he has been taking care of the first one before it was in daycare and stuff as well. So he was working a reduced schedule. He is getting back into the swing of things, and I believe the plan is for him to pick up deep dives again next year, but I'm not 100% sure. I gotta still talk with him a little bit closer to it, but I think that's the plan right now. Anyway, I'm rambling a little bit. He started the stream, and it is about CircuitPython. We're diving into the nitty-gritty. He is obviously working on cutting edge, whatever's upcoming in the CircuitPython world. As a lead developer, he's always kind of deep ingrained in whatever is coming up. So that's where the name Deep Dive comes from. I usually work at a little bit of a higher level. We're usually working at the Python level more frequently when I'm here, although we do occasionally dive into the core sometimes too. And now, after all of that, I will say thanks for hanging in there. If you are a person who doesn't know what CircuitPython is, then a lot of that may have not made much sense to you, but you can learn more here at circuitpython.org, the main website for the project. It's basically a version of Python that runs on these tiny computers called microcontrollers. There are a bunch of pictures of them here on the downloads page at circuitpython.org. You essentially, the way these work for the most part is you plug it into your computer with a USB cable. It shows up like a thumb drive. You can edit a Python code file on that thumb drive, and when you save it, the microcontroller, the little computer that's on these devices, will actually execute the Python code for you. And then your code can interface with all sorts of other hardware peripherals, whatever you have connected to the microcontroller. So in my case today, I have a mag tag loaded up here with a nice portrait of 50 Cent. And so on the mag tag, you can see it's got an e-ink display. So our Python code, our CircuitPython code that we save on that thumb drive can actually interface with that e-ink screen. We can tell it to draw pictures like I've done. We can put text. We can grab stuff from the internet in this case as well, because it has Wi-Fi. So that is kind of the very, very high level, quick version of what CircuitPython is and what it does. Again, I encourage you to go to circuitpython.org if you want to learn more. Join us on the Discord, which is linked down below as well. There's CircuitPython channels there. CircuitPython is open source. All of the code itself is open source. You're allowed to fork it and do whatever you want. You're allowed to put it on your own hardware if you want. All that kind of stuff is allowed and encouraged. And Adafruit is the company that makes it possible. They pay both Scott, who I mentioned before, and myself, as well as some other folks to work on CircuitPython and some of the surrounding software and infrastructure and guides and all sorts of other things. So huge thanks to them. And if you want to help support them and all the open source software that they support, like CircuitPython and more, one of the easiest ways to do it is by purchasing hardware from them on their website, adafruit.com. Adabox just went in the shop if you are a subscriber. So that's the way it's working out this time, is if you're a subscriber, then you'll see this. So I happen to be logged in and I am a subscriber, so that's there. If you happen to hit the website, you're not logged in or something, or you're not a subscriber, then you won't see that one. But I do encourage anyone who is an Adabox subscriber, those are now popped up there, or will be soon. I don't know if it's like they're releasing them in batches, maybe. I don't know if they're tied to the user accounts or what, but if not there for you and you are a subscriber, it definitely will be popping up soon, because I know they have been hard at work getting those kitted over at the factory in New York. So with all of that long-windedness out of the way, Today, I would like to dive into Bitmap Tools Dither. So this is an option for dithering images on CircuitPython. For anyone who doesn't know like what dithering is, this picture of 50 Cent that I have here is dithered, and actually I think quantized maybe is another similar concept that has been applied to that picture as well. But if we look at this one as a baseline, this is a bit different than the one that's showing. If we look at this one and I zoom super far in, what you'll see is there's lots of different colors in this. If we were to go into GIMP and like open up the color map, we would see that there's probably like over 100 different shades of gray in this. Obviously, it's a grayscale photo. And so there's like hundreds of different shades of gray. And so dithering is this process that takes an image like this and can turn it into something more like... let me go to this one. I accidentally, I guess I didn't, I closed it because I decided I didn't need it. Something like this one, which is the one that's actually displayed on the mag tag right now. And so this is, it started from the same image, but it's been processed with this, you know, dithering is what this sort of effect here is called, where it's, you know, has this special algorithm to kind of shade in certain parts of the image to where if you view it from far enough away, or your pixels are small enough, then you kind of get a better sense of the full image. So in this one, there's actually only 4 different colors used. There's like black, white, and then 2 shades of gray. And of those 4 colors, because of the way this sort of shading algorithm works, it makes the depth appear like more than 4 colors, essentially, to the human eye. So that is what the process is, and we have this in CircuitPython, but I don't believe that it's the kind we need for doing this specific thing. But the truth is I have never really messed with it, so that's what I wanted to do today. I figured if I have not messed with it, it's a decent chance that other folks maybe haven't as well. So I wanted to explore what is there today, figure out if it can do essentially what I just showed you, where we dropped this thing down to 4 colors and then applied the dithering algorithm to it. If it can do that, then I would like to figure out how. And if it can't do that, then I would like to look into what kind of changes maybe would be needed in the core to make it possible. I get the impression based on the 2 here that this is mostly intended for 2-color dither. I don't know if that's actually the case or not, or maybe full like sort of RGB possibly as well. So I'm not sure in that case why you would dither exactly. 2-level output, actually. So that, yeah, this definitely makes me think that it's more or less hard-coded to 2, you know, a 2-color depth, essentially, to just black and white, instead of the 4 colors, which I want, like black, white, and then light gray, dark gray, because that's what's supported on the mag tag screen, of course. The mag tag screen can do 4 different colors. It has white, black, dark, and light gray. So that is why it would be nice, in fact, to do that. Wrong one of those. Back to here now. Okay. Okay. So I have this loaded up. It's currently loading the picture that is actually dithered. Man, it is actually quite warm in here. I think I'm gonna fan on for one thing that is closest to me, and also maybe bump the temperature down just slightly. Like I said before, it's actually super sunny and nice today for the time of year it is. So I will be right back. I'm gonna try to make it just a tad cooler. Okay, fan on. We got some air moving in this room now. Bitmap Tools seems really powerful, and I use it for basic stuff so far. Happy to see this today. Nice. Yeah, I figured it can do a lot of different things, and I know that I have not messed with all of it, so I figure there are lots of folks out there who are not necessarily exposed to it. We don't have like a comprehensive... Be nice maybe to get a guide of everything that... Or maybe it should add to the Display I/O guide. Be nice to get it all documented in one place with a bunch of good examples and... supporting text about what's there and stuff, and pictures as well to show you, because it's a lot of it's very visual. You can see like here's the starting image, here's the effect, and then here's the image that it produced. So I would like to switch this to original, which is this one. So this is the undithered photo. This is just grayscale. It's got a lot of different colors in it. So I'm going to do that by just changing this here. And what we will see is that it does, I mean, obviously it only has the 4, oh, we don't have that file. Maybe I named it wrong or something. It's just original, oh, it's a JPEG actually. So I need to, so we could use JPEG IO. I think for the moment right now, realistically, I would rather use bitmap, which I think is actually this also. I think I already had a copy of this one. Let me just rename this. And then, yeah, if anyone is interested in the random like 50 cent, why is that the picture? I have a guide in the works that is a inflation calculator. It's kind of a joke based on 50 cent name. Original, I'll just call it the same thing, but it's .bitmap, of course, so it's a little different. And it should be able to run. Should have restarted, in fact. Well, no, because it stopped because of the exception, actually. So let's do this. It's not going to be on ACM1 anymore. Still doesn't like that. 50 cent original. Oh, I did this. Well, it's not original, the full word either, but invalid file. So that doesn't like that either. Okay. In that case, we have no real option but to go to GIMP. I wonder, so I know one of these does, this is actually on mode grayscale, which I think maybe on disk bitmap doesn't like. I'm going to change to indexed, just re-export it. And I'm actually just going to override the one. I don't really need the grayscale one if it doesn't work. Maybe at some point it'd be interesting to implement that as well, but okay, there we go. Okay, so this is what it does by default. So this, again, this is the undithered image, and you can see like CircuitPython does its best to try to fill it in, and it does a pretty good job. I mean, you could still tell who it is, but the shading is not as good, right? Like the sides of the face and stuff there. It doesn't do that whole technique where it's like individual pixels sort of back and forth shaded, right? Like this effect that's going on in here. And that's where the dithering comes in. So the code to do this is we need to give it destination bitmap, source bitmap, color space, and an algorithm. Let's get that stuff set up. So so for one thing, source bitmap is going to need to be an actual bitmap, not an on-disk bitmap. So let's deal with that first. We don't even need any of this stuff anymore right now. Import Adafruit image load. Calculate from 2003, 50 cent is now about 78 cent. Yeah. 1994 is when this blurb on Wikipedia talks about him choosing that name. So the MagTag project that I have worked on, there'll be a guide coming out soon, but the MagTag project shows 1994 CPI compared to current CPI, and so it's like up to 110 cent is where we're at right now, based on that scale of 1994 and all of that. So let's do Adafruit image load this, and that is going to also give us the palette or pixel shader. And to just do this way so that it's kind of one character different here. Swap back and forth. So now we have loaded that bitmap into memory rather than just reading it directly from the flash onto the display. Except for the import failed because I don't have that module. So let's turn to the old good friend circup install Adafruit image load. And because well, it's not done yet for one thing, but also because, no, okay. I'm gonna say maybe it won't reset because of the exception, but it did actually. I'm really glad that I stopped to turn the fan on. That actually feels super nice. Okay. So now we're gonna have, I'm just gonna call this dithered bitmap, which is gonna be a bitmap. It is gonna be the same size as photo bitmap. So photo bitmap.width, photo bitmap.height. So colors, it's gonna be, this thing says it needs to be 2 or this. So I guess I'm gonna go with 2, although again, ultimately 4 is what I really want to ultimately be able to do, but I gotta understand what's there today before I can try to make it do something different, because it seems like this is mostly a 2-color one. But maybe we could get 4 if we do this. I'd be curious, so we'll try that after. So source bitmap, that's going to be our photo. We're gonna say for bitmap tools, and we're gonna, well, we could get it from there, I guess. Bitmap tools.dither. So destination is the dithered bitmap. We're gonna need more for this. We need a palette and a tile grid as well. Call it pixel shader if we want. I don't know whether it's expecting 0 to be black or white, so try one and see what happens. Alright. Map is the dithered bitmap, and then the pixel shader. It's the pixel shader, okay. We're not gonna add the photo anymore to main group. Instead, in fact, we don't even really need the tile grid for that anymore. Instead, we're gonna add this one, the dithered one. And if I just run this, it should be blank, because we, of course, haven't actually done any dithering operation. Or did I halfway do it? I have halfway done it. Let's just make sure the rest of this works, because I'd rather troubleshoot anything that I've messed up already before we add in dithering. Okay. Ended up with all black, which is, I don't know if that tells us one way or another whether we want to swap those. We might need to swap these two, but we'll see here in a minute. So let's do this. Dither, so it's source, or no, it's destination and then source, and then color space. Destination source is photo, color space. One of these from, I don't know what these are from. So there is actually, I should have kept this open actually. Actually, a usage of this I found. Not very much, but there is a little bit. So dither, color space. Okay, so that's these things. I don't think it will be swapped, but... And then what else? The algorithm. So that will be of these. And I believe Floyd Steinberg is what was actually applied to the image. So the way that I ended up doing that one for 50 Cent was PIL on the PC rather than having CircuitPython do it. And well, we could get that from here, I think. And then that's the last thing? Yeah, that's the last thing. So that will basically modify dithered bitmap. It will draw stuff into it for us. You should be able to see it. Nope. Must have source. Must have a value count of 65536. So it does not like the fact that the source is indexed. In that case, I'm going to undo, which I think is going to bring me back to grayscale, and I'm actually just going to change to RGB instead. And this one I'm actually going to save as RGB. That way we can keep both. let's look at it as well. I want to make sure that I know exactly what the dither has actually done. So I want to, since this one is a different format, I want to look at it by itself and see it's the same. Yeah, it's the same as what we just saw, okay, which is what I expected, but be a shame if it turned out it was like actually different in some way, and then we started going down the path of it looks like it possibly did actually do the 4-color. Did it? So obviously it's obviously it's a little bit up. I feel like it did do 4 colors though. Maybe can I turn the light on? Light. That's obvious. That's. Is it? I gotta kind of. Okay, so that's the effect. That's actually the illusion. It is actually only 2 colors. There's only black pixels and white pixels. I've used FFmpeg. Interesting. I didn't know that FFmpeg. I mean, it stands to reason it can do really all kinds of processing, but I did not know that about FFmpeg. I'll look into that. I've been trying to actually. It's kind of like, I don't know, New Year's resolution or something. It's kind of like a thing that I decided this year. I'm trying to use as much as I can FFmpeg directly. It's like a bunch of stuff to copy paste, so I don't memorize all the insane arguments, but I'm trying to get good enough to know what it can do and be able to use it for the basic stuff instead of needing something that's ultimately just a wrapper around it. Okay, so this does not like for some reason. I wonder, maybe let's try this instead of 2. I don't. That will make a difference. Nope, doesn't like that. Color count must be that. It can't be. Color count's not allowed to be that. Interesting. So you cannot. You cannot get this then, can you? How could you get this? Came from line 36, which is creating the bitmap, and it's basically half of that, right? First of all, why would it be half of that? The other bit went somewhere? Why is there 1 bit missing? Let's look real fast at the bitmap constructor. Documented that it's. It was there a second. I don't know about this search thing. I think sometimes the search thing. But I keep telling myself at some point I'm going to look into how it works. Try to figure out what. I mean, because it must be in JavaScript. Cached some. I wonder if that's a problem? Matter. Value read only. Doesn't really say exactly what the maximum is. Let me just look also in the shared binding to see if it's is it just straight up checking for 3, 2, whatever, or does it have more logic to it than that? Value count -1. Hmm. What? Did I put it in the wrong order? No. Color count. First of all, why is it color count when that's value count? Hold on. This is line 36. Oh, creating the palette. My bad. Creating the palette. I mean, why are we allowed to create this but not the palette that goes with it? Okay, is that actually just capped there? Yeah. The dither on that? Interesting. I don't even know what that does. I don't think I've ever noticed that before. There's a dither on the palette. Say it does. Dither. When true, the palette dithers the output color by adding random noise when truncating to display bit depth. Huh. I don't know if that's doing the same thing or not. Okay. Can we... I mean, we're only using 2 colors anyway, so... What if we just do that and hope for the best? Okay. That actually worked. That did exactly what I wanted, actually. Did it? Or is it still 2 colors? Did I just get tricked again? I might have got tricked again. Let me look. It has to be still 2 colors, right? Because the palette only has 2 colors. I can't really, like, my eyes cannot really. That's a really good job, though. The dithering algorithm is so insanely good. Yeah, okay, that's actually totally 2 colors. The insane thing is that my camera that I'm using here, picking that up, like, really makes it look like 4 colors, right? Like, there really looks like there's 2 different grays in there. Unfortunately, I can't get it super well lit without the glare, so back to dark mode. But here as well is like, it looks a lot like the original one, the one we're doing that does have 4 colors. And that one does for sure have 4 colors. I've looked at it up close in the light and everything. You can see distinctly the four colors in there. And this one is definitely just 2. So that's really good for what it does. And essentially, like, basically works the same way. But it would be super... And it is the right way as well. So 0 was intended seemingly to be black and 1 for white. So that worked out. But I do think we just can't really do, like... Well... I'm not actually sure what the... Not actually sure what the other, like, what the specific colors are. Might just make it lighter. Refresh. Oh, okay. Yeah, that happens. The screen can only refresh once every couple of seconds. So if you get going too fast and you run the code, so I think maybe we could try to, like, catch that and then... Not sure how long it needs, really. Also possible that it was resetting twice. Okay. that change? Do this whole bit again. I truly cannot tell from the camera. It's same as it was before, and it is only two. It is only two colors, white and black. That is fascinating, though, since we changed the palette. So inside of Dither, it's maybe not hard-coded to indexes 0 and 1, and instead it uses, like, first item, last item? Because otherwise, I don't know why we would have gotten... I kind of was expecting to get, like, these two colors. Black and then dark gray. We actually still have white. We have white and black. So that's interesting, that it was able to work with this palette as well. It didn't actually bring in the 4 colors, but it did something. So let me try that palette dither thing. Let's look at that. So if we take this one back out, put this one back in, well, can I set dither after the fact? Photo pixel shader.dither true? Dithered bitmap. Oh yeah. Now I probably refreshed too soon. Well, we should be able to fall back now. Okay, there we go. Okay, so that did something different. Using at least 3 colors. It might be. Okay. I mean, that's pretty good. I don't think it's quite as good as the original. Well, the original that I did in PIL, the one that I had showing at first. It's pretty good, though, and I definitely did not know that that existed. Is it, but it says is it the same every time, or? So this says adding random noise. Is it actually the same every time, or does it shift? If it's truly random, the static would kind of move around on you a little bit. On a, let me jump on the chat here as well. Try setting the palette so the colors are not evenly spaced. Heavily loaded on the white side, for instance. And then also on a 4-color display, do the hex values map linearly? I do not actually know how they map, honestly. Well, I don't think 999 equals black. To the best of my knowledge, 0 is still black and Fs are still white. And then I presume 2 options somewhere in the middle-ish are dark and white. What is up, Scar32 over on YouTube? Gotta love the dithering. Yes. Definitely agree with you there. Yeah, we could try... Well, I'll try the palette there in a minute. Oh, I do want to check if it was randomized, so let's kind of get it to where I can see this. That's what I was trying to do, and I accidentally tabbed through all of my different screens. Oop, made a bunch of them on top. I don't... What is... Yes. Oh. I mean, I probably wouldn't be able to tell, I guess, honestly. get rid of the deep sleep at the end here, although it's not doing anything. I missed your description of the display. Are the 4 colors just grays? If so, then you may not be any effective difference. So there's white, black, and then 2 grays, light gray, dark gray. Should be white. Go for 999 maybe. I'm pretty sure F's all F's color. I'm pretty sure that gives you white. Same as on a regular display, essentially, OLED or anything else. Okay, so this is pretty cool, actually. I did not even know about, and this is not even bitmap tools. This is just turn the Boolean to true on the palette. I wonder what would happen if we did both? We did this and still did that also? Is that too much, Dither? Is it gonna get like extra fuzzy or something? Oh. Oh, I turned this off also. I don't think it's particularly any extra fuzzy. I think it's about the same as it was. And I believe it is still doing the 2 colors only, but it, you know, again, is convincingly making it look pretty good. Totally is. 2 colors that way. So I don't know for sure if that would have mattered having dither true here and then doing this. I don't necessarily think difference. You could try filling 4 solid regions under the picture to see the output. Filling 4 solid regions. See the output. Oh, of the colors essentially, maybe? Yeah, we could do that actually. So we could take, oh, we already have the palette. I'd be able to just use the same one. So let's just call this a test strip bitmap. It is gonna just be the full width of the display, which I happen to know is 128. Colors, we can, I think, just have 4, even though our palette is bigger. It should only use the first 4. Strip tile grid. Use the dithered pixel shader. We already have this, I'll just use it. Fill region, so the test script. Test strip. This one, and then X1, Y1, so one is going to be, so X is actually just going to be 0 for this one. That's actually easy. Y1 is going to be the height of the image. Then X2 will just make squares, so I'll say 20, and then I'm gonna make actually a variable called Y. One. Oh, also this is X1, X2, not X. What? Oh. This is not showing me the Y one. It's weird. Did it do that because I used the variable name? Interesting. Weird. This. Huh. I wonder why it's not showing the labels for the other ones. That's a PyCharm problem, not a Python or anything problem, but okay. That'll make a, that should make a black square under the picture. We could also maybe add a little bit. Value is required. Value on what? 52. That's the line that I just changed, though. The value argument on fill region. Yeah. Bro. Y1 must be 0 to 20. Yeah. Okay, that's fine. We'll just make that 0 and make that 20. And we will Y1. Probably shouldn't call Y1 anymore. Okay. Okay. I don't know why it's the entire width, but I have a black thing, black rectangle. For this one, if we did 20, 41, we get 2. Yes, that one is there. So yeah, well, okay, so the reason why the rest of it is black, actually, I know the reason why the rest of it is black, because the bitmap by default is filled with zeros, 0 indexes. The bitmap's basically a two-dimensional array of ints. Each int is an index into the palette. By default, they all start on 0. We could fill them with 3, and then it would be white. But I think it's pretty much fine. I am actually going to say, instead of 20, though, we could actually say 128 over 8, over 4, I mean, and that would, what is that? That's 32. Actually, I'm just going to hard code it. And basically fill in the rest of these. This way it'll be a quarter of the screen. Oh, look, the white one came back. Huh. Well, not came back because it was gone before, but is here now, so that's cool. Doesn't look like the white worked. Oh, I didn't change the value. That'll do it. Okay, there we go. There is our actual 4 colors. Maybe it's gonna be better or worse. Tilted maybe is better. If I don't, then maybe black, dark gray, light gray, and then white. So those do show the 4 colors of the screen. And I think the deal is internally inside of display IO mechanism, I think there is something else that is like choosing the closest one of those 4 colors, which is why when we give it the full RGB image, it outputs it using those 4 colors, and it does a decent enough job. It's basically just looking for the color that is the closest to those 4. It's not doing any fancy pixel shading or anything, but it does pretty good. So we know that we do know that those could at least show the proper colors. I don't know, like, I'm sure there's a range, honestly, you could put for each one of them and it would work because of the way that it's doing that sort of like find the nearest color, essentially. which is essentially what it does for like 565 color space as well. Let's go look. I'm a little scared of what we'll find, but let's take a peek. There's definitely not gonna be enough time to like really dig into it too much, but I'm curious to take a peek inside of Dither here, inside shared module, just to get a sense of what's going on in the implementation. So we get a height and a width from the destination bitmap. We get color space, which is gonna end up setting or equals, I don't know exactly, value 2. This is gonna basically, I don't know, I guess is equal 1 or 0. I'm not entirely sure what the logic math is gonna work out to there. We get an info from the algorithm. We could look at the other one. Actually, let's look at the other algorithm while we're here before we dive too far into the code. I'll leave this because it's kind of nice. Dither, what if we do the other one of these? So it was Atkins, I think. Atkinson. It's, I don't know, maybe a bit different. Same concept. Yeah, it's definitely different because this edge over here got a lot more solid white, whereas on the last one it actually had some light gray kind of creeping into it. Essentially catch it live if we here. So yeah, so like here there's a lot more fuzz in the white. It's different, but effectively, you know, doing the same kind of thing, basically. Yeah. But it is also still definitely two colors. It's definitely still not using 4. Row data holds 3 rows of data. Each one is larger than the input bitmap's width because MX extra pixels are allocated at the start and end of the row so that no conditionals are needed when storing the error data. MX extra pixels. Not entirely sure what that means. I mean, holding 3 rows, that part I grasp pretty well. Bigger than the width, I also grasp pretty well, but not necessarily exactly the rest of that. MX, it looks like, comes from the dithering algorithm. Output holds 1 output row of pixels. It's padded to be a multiple of 32. So that 1 BPP, 1 byte per pixel? I think? Maybe. Not sure. Anyway, it can be simplified inside the loop with this. Okay, so for sure one issue with making this support 4 colors is right now this is a Boolean, and so presumably the output is going to be holding trues and falses, which then align to 0 and 1 inside the palette. Greetings and salutations from Dark Toronto. Nice. What's up, Gordy G? Nice to see you today, my friend. Yeah, it is. Well, the sun is going down now, but it was quite sunny and warm here today. It was quite nice today, honestly. And then it says fill row, which is calling what? Is that calling, so fill row is from, roll click that? is bitmap tools dot fill row. Okay, totally. So let me read the docs instead of the C code just for a second. What is fill? There is no fill row. That's not in the, actually in the bindings. It takes a bitmap, it takes a swap, it takes luminance data, it takes a Y and an MX. Has no comment. It says what it does, but it doesn't do anything if Y is bigger than the bitmap. Zero out the padding, so luminance data. Luminance data, fill row. Luminance data. I guess it's going to take data from this and put it into the actual bitmap. But data mx minus I throw out the padding error. First and last pixel. Bits per value is 8. Else. So I presume would be the other one, 565. Guess is probably what this is doing, but I'm not positive. Data plus plus equals pointer pixel data plus plus. My pointer foo C knowledge is not enough to truly follow what this is gonna, what the actual effect that this is gonna do. I mean, I assume that we are going either from this data into this bitmap at this row with a margin. I guess that's margin X maybe? Because it is doing the first MX values there and the last MX values there, so that seems very margin-like on the sides. But it's, so this makes it seem like it's actually putting it into luminance data rather than bitmap. So it's taking a row out of the bitmap, putting it in the other array. So in our case, that is rows and a specific one inside of rows. And it's starting with the first 3 rows of the file, 0, 1, and 2 indexes, and then MX, again, came from the algorithm, the type of dithering algorithm that it used. Luminescence values are just black and white of each pixel. I don't know for sure. I don't think that it's, so like I'm only using black and white pictures, but I suspect that fill row and that this luminance data technically should work with non-black and white as well. I think that it also works with colors. I'm not sure. I guess maybe it means luminance of each color channel or something. I'm not actually sure why it calls it that or what, under what context it's using that term exactly. So this would basically load, if I'm understanding correctly, this would basically load the first 3 rows from the bitmap into this rows array. Then we're going to start up looping over rows. Start with Y, serpentine dither, going left to right. So pixel in we get from rows. Pixel out. We apply this to, in order to figure out whether it should be true or not. We set it at its X value, at its column, we set it into that out list of Booleans there, which is width plus 31. Width plus, so it okay, yeah, it holds one row, just like it says, okay. Error, so this is something to do with the dithering, I think. Kind of keeps track of this value, I believe. I don't know if it's actually talking about error. Pixel in minus pixel out. It's like basically compensating so that if it's a super dark area, you'll get more dark pixels, but if it's not all the way black, then it will still round up some and then give you some white pixels too, in order to achieve this shading. Is kind of like generally how it works inside of my brain, at least. So this one is looping I over the count. But again, that's going to come from the algorithm. X1 equals terms, again, from the algorithm. dy is terms from the algorithm. And then basically we're going to go and update rows, which was our data that we pulled out of the bitmap. And we're updating that at this location with this stuff plus itself. Basically take what was there and add this amount to it. Calculate an error amount, which then gets used next time up there. And then write pixels from, presumably from out into destination bitmap. So write pixels takes a bitmap, takes a Y value, a row, takes a list of Booleans for data. So yeah, this is gonna be tricky actually. So because this is literally made for black and white, it can't really be used for the 4-color one that I want to do. So if we're gonna add support for 4-color one, we're gonna need to not store booleans here. This is gonna have to store ints like 0, 1, 2, 3, 4. And realistically, we would probably want to decide, like, do we want to just implement 4, or do we want to implement up to 256 or up to some other number? It's twilight here. I think you're 1 hour west. I gotcha. Yeah, it's about to be sundown. Sundown is early these days for sure. But fill row would work. Fill row does not let me click that time. Fill row does have ints, but it's taking stuff out of the bitmap, not putting stuff in the bitmap, so that doesn't really help us. But I mean, there is they're like draw a line? Draw a line. Well, there's fill rect. Draw a line, boundary fill, fill region. It's not called fill rect, it's called fill region. Blend roto zoom. I mean, it could use draw line instead. So it's basically using write pixels. C code. Basically using write pixels to put data back into the bitmap here. Could theoretically use draw line instead to. It would still give it the Y the same y. In fact, it would use the same y value for y1 and y2, and then it would just use 0 and the width for x values. But it would also still, of course, need to change the calculations in here to not always give you a Boolean. Means this would also need to change. I think I mentioned that one before. But with those changes, maybe. So this also, well, it still goes. So this is like scroll up one, I think. Fill the rows by shuffling pointers. Oh, okay. Yeah. Scrolling. So really all of this is scrolling up by one. So we're working 3 rows at a time here, which makes sense because the dither algorithms, I think they check the row above where they're at to decide what they're going to do, essentially. Decide if it's going to be dark pixel, light pixel, based on the stuff around it, essentially. And so this is shifting all those up by 1. And then loading the new data. So the other 2 rows, we still have the data for. We just had to play some tricks there to move which one was in which variable, essentially. But here we do need to load the actual next row down. And then this says serpentine dither going right to left. So actually 2 operations happening here. Interesting. So it does left to right first and then right to left after, which I guess is what it means by serpentine, I suppose. Yeah, I'll wrap up the stream here in just a minute as well. I'm going to finish kind of trying to read through the rest of this and wrap my head around it. So it's going backwards, but it's more or less doing the same kind of thing. Get the pixel in, calculate whether, calculate the pixel out, in this case a Boolean value. Go through, put that into rows. No, not rows, actually out the list of Booleans. What is this doing? Why does this update rows? That part's interesting. Oh, count. That must be part of the dithering algorithm, I guess. It must have the ability to also alter the pixels around it for each step. Interesting. So not only does it decide about the current pixel, whether it should be on or off, it also could potentially change one or more of the surrounding pixels. And then finally take everything that's in that out row and send it back into the destination bitmap. Now, one thing though is I'm not sure. So this is updating rows, which is the data that we originally got out of the bitmap by doing these. But what I don't know, it does not appear to be writing it back. So when I say that it can change the pixels around it, I'm not sure that it's actually changing them in the outcome that we see, but it's changing them in its little scrolling window, which it's then, considering in the next iteration of this loop, essentially. So it kind of changes its own little temporary window, I think. Looks like Boolean is comparing the luminance to decide whether to apply the dithering. Very possible, yeah. Possible. I don't necessarily grok the math behind it all the way. I have Python code though, and being able to compare between these two will help me build a better understanding of it. But that will not come today during this stream. But then it does write the pixels back from out into the destination. And again, it scrolls the next row. And this is just basically making it so that it will refresh the area that has changed. Okay. Yeah, I have. Is it? Here. This simple example it would ignore. So this is what I actually used on the one that I showed originally. It is a Floyd Steinberg dither that can specify the number of colors. So I specified 4 as my number of colors, and that's how I ended up with the version that actually did use the 2 grays. So theoretically, what we would want to kind of do is understand the math in this and update the math in this to do the same, after also dealing with the fact that this will need to be ints instead of booleans, and that right pixels won't work as is, since that only works with booleans currently. Either that will need to be updated to work with ints, or else we would need to use draw line or some other thing. Okay, that is going to do it for tonight. Thank you for everyone who watched along. I hope you all enjoyed this deep dive into Dither and learned hopefully something new. I know I learned a load about what is possible today with the different options we have, especially the palette.dither. This is like my key holy crap moment from this stream. I had no idea this thing. I've overlooked this thing probably dozens of times because I've read this docs page a lot. Yeah, I had no idea that was there, and that's actually a pretty cool effect. Even with just that on by itself, we got a pretty good result, honestly. I will be back tomorrow over on my own channel. I will be back next week on the 21st for Deep Dive as well. I will see you then. Hope you all have a good rest of your night and a good weekend. Thanks for watching, and I'll see you later.